All right, so welcome back to another and further continuation of our look at C++, doing a review, looking at the standard template library, all of those things. All right, so let's take a look at some additional at another container. Okay, as I said, so the standard std array container class, it is better than the built-in array. Why is it better? It actually maintains the notion of its size, and it gives us the ability to have bounds checked access, right? So we can use the member function at, and that is guaranteed to throw an exception in the case that we go outside the bounds. Okay, so it's definitely better than the built-in array. Okay, but only slightly. Oh yes, and I forgot. It does allow for copying via assignment as well. Okay, so again, a bunch of pluses. However, a lot of the time, you don't know exactly how much data you're going to be dealing with. Okay, so when you don't know how much data you're going to be dealing with, using either the built-in array or the standard array generally isn't a good idea. Okay, and that's all right because C++ again has you covered in terms of the containers, right? So again, if I come back over, notice there is a container called a vector, right? So if we take a look at the documentation for vector, it kind of goes on about a whole bunch of different things, but a vector is a container that allows us to store things like we would do with an array, except for the fact that we have the ability to add elements without having to worry about the overall size of what we're storing. Okay, so let's take a look at vectors, at playing around with them, etc. Okay, so what I'm going to do, actually what I'm going to do this time, I'm actually going to create a new file here. I'm going to show you actually how to kind of deal with this and have programs with multiple mains in the same project if you don't want to create a project every time. So I'm going to go ahead and I'll create a new source, new C++ source file here, right? And let's just call it vector ex. Notice I'm going to leave CPP in there. I don't need a header file for this, so that's good. It looks like it's actually going to add something in there, so I'll leave that and then maybe actually go back and take a look. All right, so yeah, this isn't actually what I wanted at all. So let me actually just take. Get rid of that. Yeah, there we go. Okay, so sorry. Once again, let me just do Control-Shift N, or actually, just like we did here. Okay, so vector ex, and so I'm not going to add a new target for that. We'll do it sort of manually. Right, so basically what we're going to do is we kind of grab this here and we do an add executable, and then I can sort of give it a name. Call it vector ex, and then I'm just going to give it the name of the CPP file. Right. So doing that, actually, I'm going to enable the auto reload, so that should take care of that stuff for us, and then I can come into here. Okay, so we are going to have, we're going to use IOStream. We'll do our usual using namespace std, and we'll have our main function for dealing with for our code. Okay. So, I'm sorry, I didn't want algorithm. Well, I may want algorithm later, but I do want vector, and we'll go from there. Okay. So, the vector class. Well, I can create an array of vectors. I'm sorry, I can create a vector And again, I can specify the kind of thing that I want to store in it, and I'm just going to keep storing numbers. But again, you can store other kinds of things, strings and so forth. So I'm going to store numbers in this, and I'll just put in, there's my nums, right? Now, notice, I've said the type, I've said the kinds of things that I'm storing, given the variable a name, but I haven't actually put any numbers into the vector. Okay. Now we could, I could have something like 1 and 3, etc. Right. So we could actually start off having some numbers inside the vector. Right. And actually, let me run the correct one. I'll go down here to vector ex. And when we run that, notice we don't see anything output, but certainly enough, it did seem to actually create that. And again, we can verify this. Let's see. All right. So, yeah, that's right. It doesn't know about outputting those. So we'll do our begin of nums and our end of nums, and our OStream iterator, OStream buff. I don't know why it decides to pick that one first, but anyways. Okay, so there's int, and we're going to wrap C out, and we're going to do that, and then we'll have another one of those. Okay, and yes, you're right. I probably do need to include the correct. There. Yep, there we go. Okay, so we have iterator, we have that, and now we should see, yep, there's our nums. Okay, so so we do have nums. It stores the numbers 1 and 3. Okay, now here's the thing about it. If I then later on want to add additional numbers, I can do that by calling the pushback function. Okay, so the pushback member function simply adds a new element to the end of our list. So for instance, I'm going to add in the number 2. Okay, so I do that, and then again, let's see what this gives us. Right, so if I go ahead and try to print that, notice I get 1, 3, and 2. Now you might say, hey, wait a minute, they're not in order. Yeah, you're right, they're not in order because we added it at the end. If you needed to add it someplace else, you need to write the code for doing that, right? But yeah, so it actually it just jammed that right into to where we wanted. We could add in as many numbers as we need to do, right? So I could have, I don't know, I could have 8, I could have -5, etc. Right? So there, we have a number of numbers inside our vector. Okay, pretty cool. Right? So now we are freed up from having to worry about exactly how many elements we want to store. Right? The vector is going to take care of this for us. So let's take a look at some other things that we can kind of do with this and play around and so forth. Right? Once again, I want to go back over to the algorithms library just to kind of take a look at some of the various algorithms that we have. So for instance, notice these finds and find ifs, right? So if we take a look at those, right, again, it sort of brings up some documentation that begins to look a little intimidating, right? But notice, so we have these notions of find if, again, an input iterator, the first and last, and a unary predicate. Okay, what is that about, right? So notice the first and the last, that's the range of the elements to examine. Okay, and then P, the predicate, unary predicate. So a predicate simply is a function that returns a Boolean. It returns either true or false, right? Basically telling us whether we should have the element in our result. Okay, so let me give you an example of that. Suppose for some reason what I want to be able to do is to find is to find odd numbers in my list of numbers, right? So I can say find if, right? And again, we'll use our nice handy begin and end. Okay, so we do that, and then we need a, right? So the particular one that I'm going to use is, in fact, find if right here, right? So it takes the two iterators and it takes a unary predicate. Again, I could have gone through creating a separate function for doing this, but I'm not going to do that, right? What I'm going to do is simply something like this. I'm going to say, okay, I'm going to have an anonymous function, and I will simply return that the number mod 2 does not equal 0. Okay. And yes, missing that. There we go. Okay. So, yes, you're right. I need, so you can find the header, create new function. Yes, import the function, find if from algorithm. That's what we want to do, right? So there, it included algorithm, and now we have that. Okay, so what does that exactly do? Well, find if is going to return basically the particular elements that are the elements that match that particular predicate, right? So when we do n mod 2, in other words, we divide the number by 2, okay, and then take the remainder of that division. So if the remainder of dividing by 2 isn't 0, that basically means that's the definition of a number that is odd. Okay, so we're finding odd numbers, finding the numbers that are odd, right? Now, that thing returns, well, honestly, it returns something with a really, really nasty signature. Just to show you, I'm going to type it out real quick, and then I'm going to show you the fact that, honestly, you don't really need to know what it is. Okay, so it's going to return that. Right, a vector of ints, the iterator in for vector of ints, right? Oh, that is just nasty. And, you know, sometimes these things can get even worse than that. Okay, but this is where the auto keyword comes in handy, right? And I'll call this result it. Okay, so my results basically are stored in this thing, and you notice that that it's just going to, C++ can infer what the proper type of this is going to be, and so I don't need to worry about the specifying here all that nastiness in terms of the type. Okay, so let's take a look at what this returns. So, for instance, if I want the first odd number that is inside this, I'm going to say result it. Now, again, remember, iterators are based on the idea of pointers. So you can think of an iterator as a pointer to a particular element. So if I want to know what element the iterator points to, I need the dereference operator, right? So doing that gives me this, right? So notice, yes, 1 is in fact the first odd number in the list of elements, right? Now, how do we get the next one? How do we get all of them? Okay, well, what we can do is, again, we can use our copy function. And so I'm going to use result it as my begin. My end this time is going to be on the end of nums. And then I will again use good old ostream iterator of int. odds. Okay. So we're going to copy, starting with the result that we get back, going up to the end of our collection, and we're going to copy them out to that location. Okay, so let's take a look there, and notice that gives me 1, 3. Oops, we did get a 2 in there. We got an 8 in. We did get 8 in there, and we got -5. So that's probably not what we. Okay. So the issue basically is that find if, the result that we get back from find if, is really designed to find us the first element matching the particular criteria. Okay, so there are a couple of things that we can do, right? Instead of this, where we're finding the first element, and again, I mean, just to kind of show you that that's the case, right? So suppose I change this to double equals. So this should actually start me at the first even number, right? Notice right there. So there are a couple of things that we could do. One is we could actually go back to our algorithms, and if we take a look here at the algorithms, notice there is both copy and copyif. Right, so we can actually use the copyif function to be able to essentially do the same thing that we had been doing previously, right? So we do copyif, right? And so then I'm going to oops. There we are. Okay, so we'll do our copyif and begin and nums, and nums plural, and let's see, control Q brings up our documentation. So copyif, input iterator, output iterator, and then the predicate. Right, okay, so our predicate, of course, is this here for telling whether something is odd. Let me actually show you, since I'm using that, I'll say odd. Okay, so this creates a variable named oddp that gives a name to the anonymous function, so that then I could have used it here, and similarly I am going to use it there. Okay, so there I passed that in, and now let's print this out, and we'll see. Notice 1, 3, -5. We did properly drop the 2 and the 8. Okay, and then similarly, we could do the same thing. Evens look like something like this. So I'll just say, all right, auto n. And all right. No, you'll notice that that for this this single line body of the lambda, the return is in fact optional. Or is it? Let's see. What do we got? There's copy, auto, and yes, there we are. It wasn't. All right. So evens and nums are 2 and 8. Odds and nums are that. Right. So we're using copyif, and that gives us accordingly. What if you wanted to do something like the following? So suppose I wanted to say create a vector of integers as the result of my function, right? And so my function is going to be the get odds. That's going to take a vector of int. And so we'll do the typical const reference to send that along accordingly, and so forth. Okay, so if we take a look here, basically the idea is that what we want to have is some vector that is going to be our result, vector of int. Okay, and then we can do our copyif, and again we'll do our begin of nums and end of nums, and we can actually I'll call it get evens. How about that? I don't know, just feel like being even right now. And then, so you might want to say, okay, well, how about if we do the begin of results, and then again we need our little helper that might look something like the following. So auto and mod 2 that. Okay, so this will gather up all of the matches into this other vector, right? So for instance, I could say vector int evens is equal to the get evens of my numbers, and then of course we can do our code for copying to print it out. So we'll say print out the starting at the begin of evens and at the end of evens, and again and it dies a horrible death. Okay, now what's going on here? Why do we have this problem? Okay, so the problem is really subtle. The problem is that results actually doesn't have space yet for the particular results. Okay, so if you actually take a look at the code for, or I'm sorry, the documentation for Copyif, if you scroll down, typically they'll actually show you various examples for using some of these things, and they actually have an example of doing pretty much what we were doing, right? So notice they have a vector, they're copying one vector into another, and notice that here they're using this back inserter. Okay, so if we come back up here, and instead of begin here, we're going to say we're going to use the back inserter on results. Okay, so this back inserter will make sure that every time Copyif tries to copy something in, it's going to use basically the pushback function, the pushback member function for that. Okay, so then doing that, it gives us, there's our evens. Very, very cool. Let me show you one more kind of slick trick with all of this stuff. Okay, so let me go ahead and I'm going to create a data file. Okay, so I'm going to come over here and we'll create a new file. We'll call it nums.txt, right? And so this is just going to have some numbers, right? So I don't know, 13, 6, -5, 111, 8, and of course, we can have duplicates in here, right? 8 again, 10, etc. So it'll have some number of numbers. Now, let's actually read this stuff in, right? So I could, for instance, create some code to very easily. All right, so we could do something like the following. I could say, all right, let's create a vector of ints. Okay. Filed nums, And then we could do our typical code like we would do in the past. So something like, okay, we're going to create an IF stream, right? That's our in file. And let's see. So then we're going to say, all right, that's nums.text. Oop, let me make sure to properly do that. And we can put in that, yes, we are actually reading this in as that we're actually opening this for reading only, which actually now is in fact, that's right, because it is an IF stream, so that is in fact excess. All right, that other one is not. Let's double check. Pound include F stream. There it is. And yes, we're good. Okay. So, then I could begin kind of writing code for doing this. So I could have something like while in file into it would be something like this, int n, and then I could have read, as long as that's working, and then I could say, okay, file, call it file nums, not filed. That's a little strange. Yes, it doesn't like to refactor if the code is failing that. Okay, so there we go. Okay, so my file nums, and then we can do our pushback, and then we can say that we're going to push back n, and so then we could have a close for that, and finally we could say, okay, the file nums are, and again, we'll use our nice copy code, begin nums and nums ostream iterator of int and of cout. So we do that and l. All right. Okay, so our file nums, file nums, and yeah, notice we don't have anything, right? And the reason that we don't have anything is actually it didn't find the input file, right? Remember, when C++ opens up an input file, it doesn't necessarily generate an error by default. So if we want to do this and make sure that it opens the right file, basically the nums.txt file that's in the same folder as all this stuff, we could encode the direct path to this. We could certainly do that. Even easier, here's what I'm going to do. I'm going to come up here to, notice here's my project folder. I'm going to right click and I'm going to select copy path. Okay, so I've done that. Now, over here for the particular configuration that I'm trying to run, right, I'm going to go to Edit Configurations, and I'm going to make sure that vector example is selected, and I'm basically just going to set the working directory to that path. So I'll do Control V to paste in my path, and now it will automatically be looking in this directory when it starts up my program. So when I run this, now we see, okay, there's all of my elements. All right, so that's cool. Now, the thing is, this is a little cumbersome, right? Now, given what we've seen, we could in fact use a variant of our copy process to copy all of the elements from the file into our vector, right? So that is after I create the vector, I could then basically have some copy code in here and do that. I'm going to show you an even easier and really very cool way of doing that. Okay, so I'm going to comment out all this. Then I'm going to take this and move it up here. Okay, so notice I create my my in file there. And then what I'm going to do is when I create this, I will specify the following. I will specify a iStream iterator of ints initialized off of infile. Okay. And then I will create another iStream iterator on ints and notice, I actually just put in the empty braces here. So this is my end of stream indicator. This one is the beginning of the sequence. Okay, so just doing this, now I should, fingers crossed, slurp in the entire contents of that file directly into the iterator. Okay. Now, again, if that's a little weird and all that, let me kind of add in some additional stuff here. So I could have a iStream iterator of int. Let's call it infile begin. And so then we have right. So there's our beginning, there's our end, and so we just automatically will slurp in the entire contents of the file directly into our vector. Really, really handy, really slick. Okay? So that should kind of give you a good idea of using vectors and playing around with all these things. Additionally, some of the stuff that I didn't show, but you can verify, vectors have the same types of properties as the array container class. So, for instance, if you want bounds checked indexing, you can use the @member function. Just like before, you can do assignment of one vector into another, assuming that they're storing the same types of things, etc. So vectors generally should definitely be within your arsenal. Definitely should be something that you're reaching for whenever you don't know beforehand exactly how many elements you're going to use.